In this video, we're going to talk about 12.4 Objective 1, where we convert complex numbers from rectangular to polar form. So a couple equations here to know is that x equals r cosine theta, y equals r sine theta. So we're going to be using this as x plus I plus, yj. We're going to be using that here. You could replace the x's with a's and the y's with b's so that it looks more like what you're used to, but just usually we have these polar equations here. So when we're dealing with the x component, we're going to use cosine. When we're dealing with the y component, we're going to deal with sine. That's because if we look at this angle here in standard position, here's theta, here's x, here's y, and here's r. So cosine of theta is x over r, and sine of theta is y over r. The only thing that's new is that our y is in the imaginary unit direction, j. So we're going to have a j with the y component part, which is the part here that has the sine of the angle. So let's go ahead and let's draw our triangle to represent where we are here. We have a negative x value and a negative y value. So we're down in quadrant 3, and x is a negative 8 and y is a negative 15. And then this is j, right? Because this is the x axis and this is the y j axis. So 8, 15, 17 is a special right triangle. We want to solve it here. Second square root of negative 8 squared plus negative 15 squared is going to give me 17. Try to always have r be a positive number. Makes your life easier. Put r and then cosine of, we need to find theta. So the way we're going to find theta is we're going to take arctangent of y over x. So that's another thing to know, is that tangent of theta is going to be y over x. So theta is usually going to be arctangent of y over x, but it may be that plus pi or minus pi, or some other, we may have to adjust it for which quadrant we're in. This is if we're in quadrant 1. So let's go ahead and or in quadrant 4, that would also work. So that's a negative angle. We want to get our answer between 0 and 360 degrees here. So let's be in degree mode. Let's get out of radian mode and into degree mode. So arctangent of negative 15 over negative 8. And this is going to give me a positive number inside here. It's going to return a angle in quadrant 1. I know that's not right. I know I'm not in quadrant 1, but I'm going to be 180 degrees off of the answer that I want. So I'm going to add 180 degrees to my answer here. And so this is going to be to the nearest degree. We're going to call this 242 and 242. That gives me my correct answer there. Now we're going to represent this number here, negative 60 plus 80j. So a negative x and a positive y should put me in quadrant 2. It should be this one. And give the number in polar form. So let's find what the square root of 60 squared plus 80 squared is. Don't care about the negative because it's going to go away when I square. I get that it's 100. It's good. Everybody has 100, and then clear. We have arctangent of, and then y over, I do need the negative here, x. This is going to return an angle that's negative in quadrant 4. I don't want that one. I want the angle that's in quadrant 2 that's 180 degrees away. It's going to be 126.9. So there we go. It's that one right there. And let's represent this complex number graphically. Watch out that they didn't write it in its correct form here. It's like this, where it's a positive x and a negative y, so it's in quadrant 4. So it's this one. And of 25 plus 25 is 7.0711. We got that for everything here. And then we want second arctangent of, and then this is going to be y over x. And this should be negative 45 degrees. But we don't want a negative answer. We want to add 360 degrees to that to get the positive answer that's in quadrant 4 is 315 degrees. So that's going to be A. Negative and negative, that's going to be in quadrant 3. So that's over here in quadrant 3. And then assume that that's R, and let's find arctangent of negative 0.60 divided by negative 0.9. We're going to get an answer that's in quadrant 1. We need to add 180 degrees to that to get an answer that's in quadrant 3. 213.6, they're rounding to the nearest degree. So it's going to be D. Convert the given complex number in rectangular form to polar form. So let's go ahead and look at where this is going to be now. Positive x and positive y. So we have 2 root 3 for our x. We have 2 for our y. And we're going to take the square root of 2 square roots of 3 squared plus 2 squared is 4. And then second tangent of 2 divided by 2 square root of 3 is going to give me 60 degrees. I agree with that. That's my angle. There it is. Represent the complex number graphically. So it's just negative 9 as a real number. It is going to go left, not have any imaginary part. It's going to be a magnitude of 9. And it's going to be a cosine of 180 degrees, sine of 180 degrees. And that's going to give us that answer. 10j in trigonometric form has a magnitude of 10, and it's going to be here at 90 degrees. And so this is 90 degrees and 90 degrees. And that's going to give us cosine of 90 is going to be 0, so it's going to have no real part. And it's going to have a sine of 1j times 10 is going to be 10j, and that will give us the imaginary part. That is everything for this video. We'll come back next time and talk about 12.4, Objective 2. See you for the next video.